Thanks for accessing the Transformations of Functions anchor chart. This video is meant to show you how to interpret it and see the connections between the notation and the type of transformations that are happening. I've used this for my Algebra 2 course, and I'll show you how it can be applied to other math classes in the future. The anchor chart is organized by, in the very center, kind of the template of how a function can be shown, with 4 different elements that include an A, a B, a C, and a D that all have different effects on what it does to the function. I've got a couple of examples here, and I'll show you how to interpret that. Letter A, negative 2 times x plus 1 squared plus 1. Here's what I'd do. I know that first that is a quadratic function. So I have in my mind how a quadratic behaves, something like that. Then I always look for dilations or reflections first. And this is the A, this negative 2. There's another element here, that's a C, that's a horizontal translation. And then this 1 on the outside is a vertical translation. So how to interpret that? It's a quadratic. It has been vertically stretched by 2. It also has been with that negative sign. That means it's a reflection over the x-axis. And then my 2 horizontal and vertical translations are, it will go left 1 and up 1. Now this video is not meant to show you like how to graph it. There are different techniques to see it visually, or maybe even go through a point-by-point transformation. But this is just to tease out the types of transformations, and you can actually kind of like imagine in your head this quadratic. It's been stretched 2. It's been reflected over the x-axis. And then I'm taking it left 1 and down 2. So you can see where that left 1 and up 1, that new important point is negative 1, 1. And so much is anchored from that new important point, which was kind of the 0 of the one before, that it makes it much easier to identify and to graph where that function is going to end up. Okay, the second one, B, negative 1/4 times the absolute value of x. This is an absolute value function. That 1/4 on the outside means it has undergone a vertical compression because it's a fraction. The absolute value is in between 0 and 1. So that is a vertical compression. By 1/4. And then the negative sign indicates a reflection also over the x-axis. All right, let's do a couple more. I've got, let's replace those with 2 that I've got ready to go with some horizontal shifts. Okay, the square root of negative 3x minus 6. Now this one, corresponds up here to a function that has a common factor that needs to be factored out. So let's tease that out. I'm going to rewrite it here. I'm going to factor out a negative 3. So that's negative 3, and then that would be x plus 2. Let's look at it that way. Only after you kind of tease out any common factor on the inside is what you see what you really get. So this negative 3 on the inside means that it's a square root function, and it has a horizontal compression by 1/3. There's also a reflection element, so that would be a reflection this time over the y-axis. And the +2 on the inside means that I'm moving left 2 units. All right, letter D is a -2 times 1/2 x, the whole quantity, cubed plus 3. This is a cubic function. So I imagine, I know it looks, this is a rough sketch, not to scale, but it has that shape. And what's happened here? Wow, there's two different dilation components. There is that 2 means something, that 1/2 on the inside means something. The negative 1 as multiplied by the 2 means something, and this +3 corresponds to an A, a B, and a D in my anchor chart. So this is a vertical stretch by 2. It's also a horizontal stretch by 2. There's a reflection over, the negative is on the outside, so that's the x-axis. And there is a translation up 3 for this function. Now again, how to find the important points, and it's another skill to graph them, but this is kind of the best place to start, is the analysis of it on what is happening when you see these changes. So teachers, before you kind of give this to students, you could actually give it out with everything like whited out. I'll make one of those and make it available to you just as a great graphic organizer, or to have them create their own anchor chart of transformations of functions. And this will carry them up. This organizer can help them with not even algebra 2, but I'm thinking like the reciprocal functions, even logarithmic exponential, piecewise functions, and then in trigonometry and pre-calculus, the effects talk about the amplitude, period, phase shift, and vertical shift. So there's lots of opportunity to make this anchor chart to work for you. Have fun, and thanks for watching.